slope of a line. To look at the slope of a line, we first need to consider our slope formula. So slope formula says m equals y2 minus y1 over x2 minus x1. So let's say that we are given some points. So we have 2, 1, and we have 3, 2. The first thing we're going to do is label these points so we know what goes where in our formula. This is our first point, and this is the x-coordinate, so that is x1. This is our first point, and it is the y-coordinate, so that's y1. This is our second point, it is the x-coordinate, so that's x2. This is our second point, this is the y-coordinate, so that's y2. Now we have everything labeled, we can substitute it into our formula. So m equals y2, well y2 in this case is the y-coordinate from our second point, so 2, minus y1, in this case which is 1, over x2 minus x1, which in this case is 2. And now we can simplify. 2 minus 1 is 1. 3 minus 2 is 1. So the slope here is 1. Let's try again. We have 5, negative 3, and 8, negative 3. So let's label our points again. So this is our first point, the x-coordinate, so x1. Our first point, the y-coordinate, so y1. Second point, x-coordinate, so x2. Second point, y-coordinate, so y2. Substitute each of those into our formula, and we get negative 3 minus negative 3, y2 minus y1 over x2, which is 8, minus x1, which is 5. 3 minus negative 3, that gives us 0. 8 minus 5, that gives us 3. So the slope here is 0. A slope of 0 is special because that's a horizontal line. Think about if you were building a table and you put a level on the table, you would want it to be nice and level, so you would want a slope of 0. That would be a horizontal line. Let's look at another one. Number 3. 4, 8, and our second point is 4, 0. So we can label those points once again. x1, y1, x2, y2. Substitute that into our formula, and we have y2, 0, minus y1, which is 8, x2 is 4, minus x1, which is also 4. 8 minus 0 is negative 8. 4 minus 4 is 0. But that should send off some red flags. We cannot have 4 minus 4 equals 0 on the bottom because 0 in the denominator is undefined. So this slope is undefined. Notice for this one, our slope was 0 because we had 0 in the numerator. This one, our slope is undefined because we have 0 in the denominator. This is also a special line, and this is a vertical line. So a couple special cases to consider. Let's look at a couple others. In this question, we are asked to find the slope of the line. If we're looking for the slope of the line, that means that we are looking for the change in y. Remember, it was y2 minus y1 in the top. So the change in y over the change in x. So if we're looking at the change in y, we're looking at from one point to the next, how many spaces do you have to go in the vertical direction? And then how many spaces for the change of x do you have to go in the horizontal direction? So let's make some space over here so we can write it down. There we go. So on this one, let's start at this point right here. We have a nice point at the x-axis right here. So if we start right there, where we have -4 on the x-axis, let's see if we can go up and over to find a point on the y. So if I use this point right here, and I use this point right here where it crosses nicely into the corners, that would mean I would have a rise or a change in y value of up 1, 2, 3. And then from there, so we went up 3 spaces, we go over 1, 2, 3, 4, and that'll put us right here where it crosses. So 4. So our slope is 3/4. Now it's also asking us to determine the y-intercept. The y-intercept is where our graph crosses the y-axis. In this case, our y-intercept is right here, because this is where the graph crosses the y-axis. So the y-intercept is written as a point. It would be 0 on the x and 3 on the y, because the coordinate for right here is 0, 3. Let's try this one. So we are again looking for the slope and the y-intercept. So to find the slope, we need to look for 2 points that cross nicely so that we can use those as our reference. So if we look along, looks like we have a lot of ones that cross nicely here. How about we use this one right here at 2 on the y? And how about we use this one right here at 2 on the x? So that means if we start, we go from left to right. So we start here because this is our left point. In order to get to this one, we have to go down. We have to go down 1, 2. So we have -2, signifying that we went down 2. And then we have to go over 1, 2. We always run to the right. So if you start like this one, we went up and then to the right. Here we're going down and then to the right. We always go to the right. So if we go over, we go 1, 2. So remember, when you're looking at slope, we're looking at rise, which is the change in the y, over run, which is change in the x. So change in our y right here was down 2, so -2. And the run going over is 1, 2. -2 over 2 gives us -1. So our slope in this one is -1. Now we're also looking for the y-intercept. The y-intercept is where it crosses the y-axis, and in this one it's right here. So our y-intercept in this case looks like it's 0, 2. Let's try a couple more. Let's see if we can graph a line that passes through the point -2, -3, and has a slope of 5/4. So let's start with our point first. So we're looking for a line that passes through -2, -3. That means -2 on the x and -3 on the y. So that's right here. Now we're told that we have a slope of 5/4. It's a +5, so that means we go up. So here we go up 1, 2, 3, 4, 5, and then we run to the right 4. 1, 2, 3, 4. So here's our next point. So we can connect our dots. Don't forget the arrows on the end. And there is the slope. There's our line. So we have a 5/4 slope, and it goes to the point -2, -3. Let's try again. So let's say we're looking for it to go through the point -4, 1, and this time we want an undefined slope. So if we're looking at the point -4, 1, that means -1, 2, 3, 4 on the x, and 1 on the y, so right here, and an undefined slope. Do you remember that special about undefined slope? An undefined slope means that we are looking for a vertical line. So a vertical line looks just like this. Here we go. There are some special cases of lines that we can consider too. sometimes you'll be told to find a line that is parallel or a line that is perpendicular. So if we're looking for parallel, that means that you have the same slope. So parallel is the same slope. If you're looking for lines that are perpendicular, that means that you have an opposite reciprocal slope. Let me show you an example. So parallel slope, that means that they have the same slope. Same slope means that the same m value is going to be used in both cases. So let's look at a parallel example. Let's say that we have 6x plus 2y equals 8. And first thing that we need to do is find the slope of this. So in order to get the slope, we need it to look like y equals mx plus b, because m is our slope value. So in order to get our slope, let's get this into y equals form. So that means we need to move our 6x over. So 2y equals negative 6x plus 8. Divide both sides by 2, so negative 3x plus 4. So that means that our slope is negative 3, or negative 3 over 1. So if we're looking for a parallel slope, then our parallel slope would also be negative 3 over 1. Let's say that we wanted to find a parallel line and we wanted to go through the point, let's say 2, 4. So that means that we want to find a line that is parallel that goes through our point 2, 4. So parallel to 6x plus 2y equals 8, and passing through the line 2, 4, or excuse me, through the point 2, 4. So that means that we need what is called our point slope form. So we have y minus y1 equals m times x minus x1. This is point slope form. It is called point slope form because it uses a point, x1, y1, and it uses a slope, which in this case is our m. So we can substitute everything in. Here's our 1 point, so here's x1 and here's y1. So substituting in our values, we have y minus 4 equals, we want parallel, so use our same slope from before, and then we have x minus 2. So y minus 4 equals negative 3x plus 6. Add our 4 to both sides. So looking at a parallel line, we would have y equals negative 3x plus 10. This line and this line will be parallel, but they will pass through 2 different points. Let's say that instead of parallel, we wanted it to be perpendicular. So everything's going to stay the same, except for right here. Instead of parallel line, let's find a perpendicular line. So a perpendicular slope means that you take the opposite of it and you take the reciprocal, which means you flip it over. So our parallel slope was negative 3. So our perpendicular, in geometry, the symbol for perpendicular looks like an upside down T. So our perpendicular slope is going to be the opposite. So instead of negative, it'll be positive. And 3 over 1, flip it over, becomes 1/3. Everything else in our solution is the same. So we have our point right here. Here's our x, here's our y. So we have y minus 4 equals 1/3 x minus 2. This time we have our m, which was our negative 3 before. Using our perpendicular, switches it, flip it over, and take the opposite sign, so 1/3. Distributing this, we get y minus 4 equals 1/3 x minus 2/3. Now we need to add our 4 to both sides. So if we have negative 2/3, and we're adding 4. We want this to be over 3, so we can multiply top and bottom by 3. That'll look like negative 2/3 plus 4 times 3 is 12, 12/3. Negative 2 plus 12 gives us 10, so we are left with y equals 1/3 x plus 10/3. This line and this line will be perpendicular, and this will pass through the point 2, 4.